Alright, so I'm Dave Simons. I'll be presenting how to do backup provisioning with Bacula and Puppet. It's just a configuration management talk, I suppose. I'm Dave Simons. I'm a Linux and open source consultant at innovates.eu. You can find me on Twitter as @mewpie or on GitHub as simonsd. Innovates.eu, we're an open source consultancy company. We do mostly system administration and some web development, but we also have a few people doing embedded development, some stuff with routers and whatnot. We have our main office in Belgium and a few offices in the Netherlands, Ukraine, and Czech. So, Bacula, I'm assuming everybody here knows Bacula. Who doesn't? Yeah, that's what I figured. But just to make sure, it's a network backup system. It's written in C++ mostly, if I'm correct. Correct me if I'm wrong. It runs on Unix, Mac, and Windows. And apparently, since now, with Barreos, also on Windows for the storage daemon and the director. And of course, it is open source. It consists of a few components: the director, the storage daemon, and the file daemon. And if you want to expand into that, the catalog is also a vital component, the storage backend. The firewall, not to be underestimated, because if you forget that one, nothing is going to work with the network backup system. And the interfaces to interact with Bacula. The director isn't just going to start jobs itself. Well, once it's configured, it will, but to interact with it, you have the web interface, the bconsole, or the GUI. What's it called? BAT, I think. So a little overview. We have the director, top center. This one has the catalog as its backend. It's essentially just a database where it stores its information on every backup he makes. You have the web interface, text console, and GUI console interacting with the director. It allows you to send commands directly, start jobs one-off if you want to. The director connects to both the storage daemon, bottom center, and the file daemons on the left. Yeah, just essentially to send commands to the file daemon. I want to back you up right now, give me all those files, or tell the storage daemon, watch out, incoming backups, open up the storage medium. And the storage daemon, of course, interacts with all the storage medium. You can be fairly flexible about the storage media. You can back up to disks or to tapes or to USB sticks if you want to. I've even seen some mentions of CD and DVD drives, though I do not see why you would want that, but it's possible if you really want to. In a classic setup, you would have to have one or multiple persons manually install and configure the director, the catalog, the storage daemon, the storage backend, and then each and every single file daemon. And the first few parts are easy. Well, all the parts are easy. The first few parts are relatively fastly done. But all the file daemons, it can be done in 10 minutes if you have like 5 file daemons. But if you have a couple hundred hosts, a couple thousand hosts to back up, this can take quite a while. Not to mention, you really don't want to do that, because there's a bunch of things wrong with doing all this manually. If you do this manually, it's going to take you a lot of time. There's no way around that. You can try scripting some of this, and it'll work for the most part, but you'll always have exceptions. Some machines need different file sets to be backed up, some machines need different schedules, whatever. You're going to have to adjust some things. Plus, it's error prone. If you have a single person doing this, you can do 20 machines automatically. You can just type and type and type, and most of it will be right, but you're going to miss one character somewhere in the config file, and then you'll be debugging for 2 hours. If you're lucky, Bacula will tell you in the output somewhere that in this config file on that line you made a mistake somewhere, but that's not always the case. Sometimes it's in a password somewhere, and this password looks okay to you, but you're missing one character in there somewhere, and nothing will work. And of course, it's really repetitive. If you have to do this for 600 hosts, you're gonna barely be able to stay awake. So in comes Puppet. Puppet is a configuration management tool, one of many. It's written in Ruby. It has a server-client model if you wanted to, but it can also run standalone. It's completely open source, though there is also a Puppet Enterprise version, like with bacula Enterprise, that adds a few things. But all of the features in Puppet are completely open source. So it's not that some of the features are restricted to only enterprise usage. And of course, it runs on all of our platforms. It runs on Unix, Mac, Windows, whatever you like. Some features aren't available on some platforms, like services. I think that's not entirely implemented on Windows, but yeah, that figures, I suppose. So Puppet is also made up of a few components. You have a Puppet master, which is essentially the server component, if you wish to run a server-client model. You have the Puppet agent, which is the client in the server-client model. You have Puppet apply, which is if you want to run standalone. You have Hiera. Hiera is essentially a data store, which you can use to store data. PuppetDB, which is a backend for the Puppet master. It's pretty much like in bacula, a backing database where you can store information about the jobs you run, the hosts you run against, all kinds of stuff. mcollective is a, how would you call that? It allows you to remotely execute stuff on hosts. So instead of having to log into every machine and tell it to start the service, for example, you can use mcollective and say start service NTP on all those hosts. And again, just like with bacula, you have some interfaces. You have mostly web interfaces. The Puppet dashboard, which is a part of the Puppet Enterprise package. And you have Foreman, which is being developed by Red Hat. And is aiming to be more of a complete machine lifecycle application, which allows you to not only provision hosts, but then manage them using Puppet and check out reports about these hosts, see what kind of specs they have, lots of things. But personally, we use Foreman, we're really happy about it, though we're not using all of its functionality. And well, a couple of years ago at least, the Puppet dashboard was really underdeveloped. It was total crap. I'm starting to have some more experience with the dashboards the last couple of months, since I'm at a new customer where they have Puppet Enterprise. They seem to have made some improvements, but it still has a long way to go. So a little overview. Let's start with the agent, which is the client-side component, as I mentioned. If you run Puppet, then you usually run in either two modes. You can run as a daemon, so you can just run the Puppet agent binary as a daemon, and it will periodically connect to the master and request its catalog. Or you can run it from cron and just say every half hour, every hour, run against the master and see if there's anything new. What the agent does is essentially it will connect to the master and it will say, I want my catalog. What's new? The master will say, okay, well, who are you? You know, what's your host name? Are you qualified to connect to me? Will I give you a catalog? Because this catalog contains all information about a system. It contains passwords, but it's all encrypted, so no worries. It contains passwords, it contains file systems, it contains lots of things. And you don't want some malicious fiend on your network just saying, hey, let's get a list of everything on this system. That seems like fun. That's bound to end up wrong. So the master first also functions as a certificate authority, and you have to sign a certificate created by the agent before it can actually connect to it. There's ways around it. You can have the master auto-sign certificates. I can see a use case for this in very large deployments if you have multiple thousands or 10,000s of machines. But auto-signing is generally not recommended. Because again, some malicious person could just present itself as an agent and guess a name that might fit into your naming scheme, and you would automatically give him a certificate to allow him to connect to the master. So once the certificate is signed, the master approves, you can actually request a catalog here. It will start parsing all of the Puppet code you've written. It will grab all the modules, all the classes, all the resources, compile them into a big catalog, and ship this over XML-RPC, over HTTPS, as a catalog to the agent. The agent will at that point unpack the catalog, and it will interpret it and apply all these resources. So it will first, it won't just blindly start applying stuff. It will first check what is on the system. Has this resource been defined before? If you specify a file system that has to be mounted, it will check, is this file system mounted? Is it mounted in the right place? Is it the right file system type? If everything is okay, it'll just skip the resource. If it's not okay, you will mount the file system, you'll create the user, install a package, whatever you want. Until you arrive at the system state you predefined, the system state you described. So Puppet Apply wasn't on this slide, but essentially it does all the same things as the Puppet master and agent do, except it cuts out the XML-RPC over HTTPS connection. The Puppet Apply does all the compiling of the catalog, parsing all the modules, all the files. It compiles the catalog and it executes it itself. The reason I say it's a subcommand is that all of these commands, the master, the agent, and apply, they're all rolled into a single command, all called Puppet. And I think it makes sense since, well, it does all the same things, so you might want to not split it out into 3 different binaries and then duplicate all the code. Next up is Yara. It's a data store, as I've mentioned. It contains all of the configuration data you want to use in Puppet, so you can abstract your code from your data. It's easily written, it's just a YAML based, so the configuration and the data is all stored in YAML, which is really easy to write or to parse with other tools you have. And it has an adjustable hierarchy. So this is key because you can define a data store, and if you have like 3 levels, you have a common level, you have one level for environments and 1 level for clients. That'll work in most deployments, but for more complex scenarios, you might want to add a few levels to that. Say you have multiple data centers, say you have multiple different roles for machines, you want to expand upon that hierarchy. So on the right, I put the configuration file for here that we're currently using. You can see it's just calling a backend YAML. There's other backends. I believe some people have written a GPG backend, which allows you to put all your configuration data in GPG encrypted files, and then you can enter the password once, the daemon will open it, and you can read it. Again, protecting you from malicious people trying to read your data. Which is always nice. The logger console, well, it just spits everything out on the console. I think that's pretty self-explanatory. And then the hierarchy. It goes from top to bottom, and as you can see, common is defined all the way at the bottom. So it's not so that it will first check the common level to see if we have a value for this particular variable. It will start at the top level and see, is there an override for this client in that environment with that host name for this particular variable. And then you'll just proceed across the levels. So in our case, we have roles. A role can be, for example, a DHCP server, an NTP server, a Puppet master, whatever you want. These can differ per environment as well. So in production, for example, you want to have all hosts pointing towards your production NTP server, whereas in development you want to point them at your development NTP server. That's a really crappy example actually, because NTP is pretty much universal. But for something else, like DNS, you might want to point your host toward different machines in production than in development. And the same goes for hypervisors, the locations. As you can see, we created some custom facts that, like data center and hypervisor, that allows a Puppet to know which hypervisor our virtual machines are running on and in which data center they are. So we have data centers in, for example, the Netherlands, in Germany, and in every data center we have our own network setup. So you have your own DHCP server, DNS server, you have your own NTP server, and you don't want your machines in the Netherlands pointing towards your DNS server in Germany, because that's just a lot of overhead that you want to avoid. And this kind of setup allows you to specify different NTP servers and whatnot per data center, per hypervisor, per whatever. And all the way at the bottom, the common level, where you can just specify same defaults. Say you have a data center or you have local machines you want to test on. Well, you're not going to use your DNS server in any of your data centers. So you might want to point them at the Google DNS servers or something. And finally, the data dir is just a pointer to where you store your data. Generally, that's etc Puppet, but some people might put it somewhere else. This is a little overview of our Hera tree. So as you can see, we have a common.yaml all the way at the top. We have a subdirectory for clients and then a subdirectory for the production environment. We like to split this out so it's nice and clear, because you can use the host's full host name, like client1.production.example.com, but that's going to get messy real quick. If you have a couple of hundred hosts in every single environment, then you're going to end up in a directory, you're going to see 500 files, and it's like, yeah, crap. Now I got to start looking, where is this file? This gives you a bit of a better overview. The environments, again, only production this time. You can put multiple files in here and it'll just load them, allowing you to specify a bunch of different things. Well, the same for hypervisors and locations. It's all the same principle. It'll just load these files in, all of them, and you can tell Hera with the hierarchy in which files it should look first and where you want to have your overrides. Next up is the Puppet language. So far we've been talking about Puppet as a tool, but there's also the Puppet language next to it, which is a bit confusing. The Puppet language, as I've said, it's written in Ruby, but you don't write your code in plain Ruby. Your Puppet code is written in a domain-specific language, or DSL for short, of Ruby, so it has a very Ruby-like syntax. It's pretty much exactly the same, but instead of writing plain Ruby code, you write resources. You define how you want your machine, what kind of state your machine has to be in. These resources, well, you have a couple of different ones. You have regular resources, virtual and exporter resources. But we'll get into that later. Your resources are put in classes generally. You don't specify resources directly for a host. As a good practice, you can do it, but it wouldn't be very clean. The classes go into manifests, which is just a fancy word for files. They all have a .pp extension. I don't know why they wanted that extension, but they must have liked it. And these manifests mostly end up in modules. And modules are just a logical collection of manifests regarding a certain application. So if you want to set up memcached, for example, then you would put all manifests regarding the installation and configuration of memcached into the memcached module. And these modules are really handy because they're pretty much plug and play. They should be completely abstract. There should be no configuration done in there. This data should be in here. If you make them completely abstract, you can share them. You can put them on GitHub, you can put them on Puppet Forge, and other people can use the code you've written to deploy a certain service the same way. Always handy. As I've mentioned, there's a few different resource types. There's 2 types of types, and that's going to sound really confusing. So you have this kind of resource types cron exec file group user amount package service. I think it's fairly self-explanatory what they do. They just define a cron job, or they define a command you want to run. They define a file you want to put somewhere, a package you want to install, the amount you want to have. And the other resource types, the regular and stuff, that's a way of defining them in Puppet and using them in Puppet. But again, we'll talk about that later. On the right hand, I've put a few different resources, a few examples. They're really simple, but you should be able to make them out yourself. So first we define a file, we give it a name. The name in this case is also the path of this file. You can specify the path separately as a parameter if you want to, but well, usually it makes sense to identify a file by its full path rather than some obscure name. So we've used the path as the name here. Content, in this case we've used the template, but you can also just put a string there. If you want to, under mount foo, put a file that has a bar in it, then you can just enter bar here and that'll work. You can specify what owner and what group the file should have and what mode. And this is really handy because you can restrict permissions a bit. Not all tools can do that. The second resource is a cron job for a simple MySQL backup. It allows you to specify a command, which user you want to run as, which hour and which minute you want to run this job. You can specify arrays here, or you can do some magic in there, whatever you like. And then we have a require. So this means that right now you can see that the cron resource is below the file resource, but Puppet doesn't care about that. Puppet will just parse all the files, it will list all the resources, it will put them in its temporary catalog, and only then will it start ordering them. So if you don't specify this, it could be that your cron job would be defined before you actually have your MySQL backup binary in place. For a cron job that doesn't really matter because it's not going to run until 15 past 12. But if you're running a command and your executable isn't there yet, that's not going to work very well. So you can specify some relations between these resources. In this case a require, which requires that the file be present before the cron resource is put in place. You've also got before, for example. You can put that in file and say that the file has to be defined before the cron resource. You can do some pretty neat stuff with that. You can ensure that your ordering is correct. Because trying to start a service before your package is installed generally doesn't work. The last one is a resource, a user, bacula in this case, and again, some parameters to define how you want this user to be on your system. You want it to be present. You can also say, I want it to be absent if you have a certain user, say a colleague that leaves you and you want his account disabled on all machines. You can, well, if you're lucky, you have LDAP, and then you can just disable it in LDAP. But if you're not lucky, then you have to manually disable or remove this account on 600 machines. Not a very fun thing to do. But if you just put ensure absent here, you wait a half an hour and Puppet removes all these users from all your machines. You can specify which group ID you want, which UID. You can specify a password. You can put it in plain text, but preferably you would put it as a hash. But that's not very readable, so I didn't use it here. You can specify a home directory. You can specify which shell. You can specify some more things. If you ever created a user, you know what the options are. A little example of a Puppet tree. So generally this is what a Puppet tree would look like. You would have a manifest directory containing your manifest, a modules directory containing your modules. I love it how directories are aptly named. And then you just put them all there. And this makes sense, but you might think, how are these all loaded? Because you can just have everything parsed, but maybe you have some files in there that you don't want to be parsed. Well, that's going to be very annoying. But there's two different ways of loading files in Puppet. One is manual imports. So for our manifests, we can manually import everything in defaults star.pp, which would be all manifests in that directory. If you would put, if you would have a single file that you don't want to include anymore, you could just give it a different suffix and it would be automatically excluded. This, however, is deprecated in the latest versions of Puppet. They're doing some really weird stuff with loading entire directories at once, and people still have to figure out how this works, because apparently there have been a few slight accidents with that already. And then you have some auto-loading magic, which is for the modules. The modules are automatically loaded. If you have to specify every module to import, that's also going to be a tedious job. So they just expect you to say where your modules are located. In this case, well, in the first example, with Puppet apply standalone, you pass it on the command line and you just point it towards the directory your modules are stored, and then you give it the manifest you want to run. Or in the case you run a Puppet agent, you can specify it on the master and say which manifest and which module path you have, and it will by default always use those. As you can see in the manifest and module path parameters, there's a few variables. This is very handy because if you would like to use multiple environments in Puppet, so you have a production environment, you have a development environment, they might be running the same code but at different points in time with that code. And you can just put multiple directories under environments, one for production, one for development, and you can just have this snippet, and the moment an agent connects, they will automatically fill in the variables. An agent from development will fill in development and automatically grab the modules and manifests from development. So this is nice. It's okay if you have 3 environments again, if you have to define this in the config file, but if you have 17 environments and they change regularly, then it means you will have to regularly adjust your config file, which is also not a very fun job. So, modules. As I've said, modules are auto-loaded, but that also means they need some kind of structure, so Puppet knows how to load them. If you just put all of your code in one directory, Puppet might be able to load it, but there's not just manifests. There's also templates, there's also files. You have lib and facts.d, where you can write actual Ruby code that Puppet will interpret and allow you to create custom resource types with, custom facts. Yeah, just facts are variables actually. Puppet collects this before it starts running. It runs against the system and starts collecting facts about it, so how much RAM do you have, what operating system. And this allows you to create custom facts. So for example, for a hypervisor fact, we check what network range it is in, or what MAC address it has, or something that allows us to see which hypervisor it runs on, and then put that in a file so we can read it and use it in our code. There's also tests and spec, because, well, we're a fan of automation, and you can write RSpec tests, for example, that test your code on a syntax level or a functional level. So you can just have all your code pushed into Jenkins, automatically tested and deployed on your Puppet master. Very handy. Alright, some examples. This is a basic manifest, in this case for bconsole. So setting up bconsole is really easy. You just have to install a package, create a configuration file, and that's it. You don't even have to start a service. It's of course dependent on the director, so you do need to configure that one beforehand, but as you can see at the top, we have a few parameters. In this case, they all have defaults in the form of variables again, pointing towards a parameters class. This parameters class is just a generic class where we collect all the parameters and their default values, because a few of these variables you might want to reuse in different classes. Like the config root, if you set an alternative config root, instead of etc bacula, you want to put it under opt etc bacula or something, you can specify it in the params class, and the other classes will automatically inherit this. So if you only want to install the bconsole on a certain machine, you can still be sure that it's configured in the correct directory. You can see right below the parameters that it inherits bacula params. That's just a class name, because Puppet has already parsed all the modules and it knows where this class is defined. It's loaded it, but it hasn't instantiated it yet. So then we open the class itself. We install the package with the variable name. We ensure it's present, which in this case just means make sure it's installed. But you can also say ensure 12.0, and then it will make sure that version 12.0 of the bconsole is installed. And secondly, we have the file, the bconsole config file, which again we just ensure that it's a file, it has the correct owner and group, correct mode, the content comes from a template, and that it requires the bconsole package. Otherwise, you might get into the situation where you install your config file, the one you want to have, and then you install the package and it just says, oh, there's a config file here, let's kick it aside and let's put the template in place. Yeah, that's not going to work again. In that case, you have to run Puppet twice. This allows you to do it in one run. This is the template associated with the bconsole configuration. The actual configuration of the bconsole itself is just the bottom part, where you list the director. The variables are automatically filled in. And the top part is a little Puppet header that we like to put in, that sets which Puppet master it was served by, which module this came from, which template source this came from. Because it's really handy when debugging to see where this all came from. We've had situations in which people installed a new machine in development that was all of a sudden connecting to the production Puppet master. You don't want that. And so you're asking yourself, like, I made a change in the code, and why isn't this applying to this machine? I've run it like 5 times, the code has to be parsed by now. And then people figure out, oh crap, it's connecting to the wrong Puppet master. That's not going to work. So just putting this simple stanza in there allows you to debug this problem in 2 minutes instead of in 2 hours. Again, we've been a bit conservative about this. We first also thought we should put in the environment here, but that means that as soon as a machine switches environments, all of your config files will be regenerated. And that's going to create a lot of noise in your output that you really don't want, because you won't see what changes were actually made. All right, the virtual resources. So I've mentioned before there's regular resources, virtual resources, and exported resources. The regular resources are just plainly defined, and they are instantiated on the machine itself immediately. Virtual resources allow you to put an @ symbol before your resource, and it means the symbol will be, it means the resource will be loaded. Puppet will know it exists, but it won't be instantiated. Unless you realize it. This is really handy in case you have some users that you only want to be present on a machine if a certain cron job, for example, is defined. If you have a nightly backup job, then you are going to want to have a backup user to run that as. But you might not want to have a backup user on all machines that you don't require backups of. There's 2 ways of realizing virtual resources. One is plainly with the realize function, in which you can specify the resource type and its name. And the second one is a collection. These collections allow you to collect multiple resources at once. In the plain realize example, you can also specify an array, but that's still going to require you to manually enter a few resources. Whereas if you use a collection, you can just tag all resources for a certain project, for example, with a specific tag, and then just collect that tag, and you will have all the resources automatically imported and instantiated on that machine. It's a fairly nice concept, but generally speaking, we don't really use it much because of its limits. It's fairly limited in functionality. If you just want to instantiate a single resource based on a simple condition, you can just put in an if clause. Then you don't have to screw around with virtual resources. But virtual resources were a bit of a first, and it led up to exported resources. Now, exported resources are way cooler. So, exported resources do the same thing as virtual resources, with the slight difference that instead of just not instantiating the resource, it exports it to the backend database of the Puppet Master. And it doesn't get instantiated on this machine. There you have to work with collections, and you can collect these resources on different machines. So say you have an Isinga check, in our case, for the file daemon. You want to define the Isinga check along with configuring the file daemon. But the Isinga check doesn't have to be defined on this machine itself. It has to be defined on your Isinga server. So you export the resource to the Puppet Master, and the next run your Isinga server makes, it collects all of these resources and instantiates them on your Isinga server. Now this is really nice because it allows you to do a lot of stuff automatically. For every machine we install, we automatically install some stuff, NTP, DNS set correctly, whatnot. And we also, if we set up a machine to have a file daemon, we automatically export an Isinga check for it. So we don't have to do this manually. This makes that you can write some very clean code that is reusable for every machine. This is the bacula module tree. Apparently some is falling off on the top. It's a little overview of the bacula module. You can see it's fairly extensive. I made it possible to define every single resource in bacula. So you can't just install a director, a file daemon, or a storage daemon. You can also define catalogs, file sets, jobs, messages if you want different outputs, pools, schedules. You can, well, configure every part of bacula. It's really flexible. So the module shouldn't limit you in your ability to be really flexible about how you configure your bacula instance. And at the bottom there's templates. There's one for every single one of these resources, but most of them fell off because it's, well, too much to list. So, an example of how to configure the director. This is an actual class we're using. It just installs your bacula director. So it just includes the class, and the class will install the package, set up the configuration file, start your service. It will define a catalog. We're using the bacula directory loading thingy snippet on the wiki. So every single resource is split out in a single directory. You have a catalog directory in which every catalog has its own file. That makes it really easy to split everything out and keep it nice and neat. We export a database to the Puppet Master. That will be picked up by the database server in that domain, so you can have the database automatically created. Of course, it has the same rights as the bacula catalog. You can see with the Percona rights thingy, that sets the correct rights for the database, that we're using here a bacula prod.db name, for example. This is an example of how variables get loaded from Hera into Puppet. So otherwise you would have to hardcode your database password for both the rights of the database and the catalog. In this case, you can just use the same variable to specify this, to make sure you don't have two separate passwords. And all the way at the bottom, we have the Isinga check to make sure the bacula directory is still running. Now, all of this is just a very generic class. So if we want to have multiple directors, we can just have multiple machines, include this very same class, and all the configuration, all the specific configuration, is done in Hera. If they have a different host name, they have a different mount point for their, well, they might want to use a different storage daemon, they might want to use a different backend catalog. You can do all of that from here. It's really flexible. Configuring the storage daemon is, well, pretty much the same. You include the bacula SD class, you say which storage directory you want to have. This is a call to Hera. It looks for the bacula storage variable, but if it doesn't find any of those, it will fall back to the default, being SRV backup bacula in this case. And then automatically, again, we export and async a check to make sure the storage daemon is still running. Then the file daemon, that's more of the same. Configure the file daemon, export the bacula job to the director, create some pools in our case, because we're using 2 separate pools per host. I don't know if that's a good idea. Somebody can tell me that after this, but I thought it was a good idea anyways when I first set it up. So. And again, the async a check to make sure the file daemons are still correctly running. Of course, this was a talk on Puppet and bacula, but it's just one combination of tools. You can use many other tools for configuration management and for backup. For configuration management, we have Chef, Ansible, Salt, CF Engine, PCFG2. They're all simple tools, well, simple. They're all tools that do their thing very well. And you can just as easily set this exact thing up with Chef, for example. It has all the same features, it just does it a bit differently. And on the other end of the spectrum, bacula also has a few counterparts. Bareos, in this case, pretty much a clone. rsync, rsnapshots, rdiff, backup ninja. You can pretty much have whichever pick you like for your infra, whichever works for you. Are there any questions? Yes?
Did you use some Puppet module from Puppet Forge, or is your stuff published on Puppet Forge, or there are some stuff around on Forge for bacula?
All right, so the question was, do we use any modules from the Puppet Forge? Do we publish on Puppet Forge? Well, the thing is, the Puppet Forge hasn't been around for that long. Most people don't like it because it's fairly manual. As in, you have to manually go to the Puppet Forge, you have to download a module, you have to manually upload everything. Whereas before the Puppet Forge existed, everybody just used GitHub. And people tend to push their modules to GitHub, and people tend to first look at GitHub if they need a module. In this case, the Puppet bacula module is on my GitHub. I think it's also on the Inuit's GitHub, and we publish this whenever we update it, normally speaking. So, and the Puppet Forge, well, yeah, sorry, but we really don't use that. It's, yeah, too little, too late. Anyone else? Yes? Okay. We do not like that question.
Because we really have to put a lot of effort into configure Puppet correctly. So if there's a number of servers, you actually need to have an advantage.
Well, it depends on how you're using your servers. If your servers are simply build hosts on which you compile an application, for example, then you're probably just going to set up NTP, DNS, and DHCP, and that's it. But if you're going to go very far in this, and you have a machine that has a complete application stack, you have a web server, an application server on top of that, you're running a number of apps on it, then the point where you want to start using configuration management is very soon, actually. I think
the question is how far you want to go with that.
How far you want to go with that? Well, as far as you'd like. We've seen people that simply...
I meant that that's a question for him.
Oh, yeah.
Not how many servers he has before he wants to use Puppet, but how many things you want to manage with Puppet. You can start by just managing NTP or bacula. But Puppet is very simple. It's just the learning process to get into it is yeah, but it's fun. I guarantee that.
Sadly enough, fun is not always paid.
Yeah, true. Yes.
Do you also experience with running this on a business platform?
No, I haven't had the pleasure. Anyone else? All right, then this is the end. Oh? Oh, yes.
One other question. You mentioned Foreman, and compared to here, what would you recommend for the data output, or is how do you call it? It's an external node specifier for Puppet?
An external node classifier, yes.
Classifier. Even the exported resources can be pulled out of the Foreman database. Is that anything you tried with the backup stuff?
No, we haven't tried that. But I wouldn't be very eager to try to use Foreman for the exported resources because right now we're using PuppetDB, which is some very funky stuff on a JVM with a PostgreSQL backend. But before that, we were using MySQL, and we noticed that after you put a few hundred resources in your database, that it starts getting really slow. So if you have a single server that needs to collect a couple of hundred, a couple of thousand resources, then the single node is going to be running for minutes before it actually finishes the catalog. And nothing might be changing. It just, yeah. So if you use PuppetDB, it's really fast, and we're really happy about that. It also gives you a lot of nice functionality, because PuppetDB can be queried externally. You can see what resources are in there, what's defined. It's got a REST API, so that's really nice. You can plug in a lot of your tools into it. So I wouldn't be very eager to try Foreman. I suspect it might be a bit slower, whereas PuppetDB is developed by and supported by Puppet Labs, the company developing Puppet itself. So,
Go for another database.
yeah.
And the Foreman integration is not the same as exported resources.
Right, exactly. But you can do the same trick with an Nagios
Yeah.
and stuff. You can do that as
Yeah.
well. That one database. Just a question.
Yeah, I think it should be. All right. No more questions?
Thank you, Dave.
All right, thank you.